Alright, let's move on to 3 and 4. I think we're actually all done with the graphing part. Here, let me look at the... Yeah, we're done with graphing. Okay, this one. Once again, look at your system and see what sort of features it has. This one, I got my just straight up numbers on the right side, and then I got my variables here on the left. Okay, this does not lend itself or like suggest doing substitution, because if you want to do substitution, you have to solve one of the equations for a specific variable. But it does suggest that we use elimination. Here, if we look at these 2's here, that's a signal, right? If you got similar coefficients, you can use elimination pretty easily. So if I take the top equation and I subtract the bottom one, I'm going to get rid of the y's, because we got positive 2y and positive 2y. If we subtract those, the y's disappear. So I'm going to do that. So I got 7x minus 8x gets me negative 1x. The y's disappear, so plus 0. Equals, got 24 minus 3, minus 30 gives me negative 6. So now all I got is negative x equals negative 6, which means x is just 6. You can get that by times by negative 1 or dividing by negative 1. Now we got x. You just take it and plug it into one of your equations. I'm going to plug it into, let's look at the bottom one, okay? So 8 times 6, because that's what x is, plus 2y equals 30. And now when I get y by itself, I should probably multiply the 8 and 6 to get 48. And that makes it a little bit easier to work with. I'm going to subtract the 48. Subtract 48 to get 2y is negative 18, because 30 minus 48 is negative 18. Divided by the 2. Sorry, I'm running out of space there at the bottom. I now have y equals negative 9, because negative 18 divided by 2 is negative 9. I now have y equals negative 9. So you get the point 6, negative 9. Get used to writing it that way. Move on to number 4. Okay, this one is a little bit different than 3 and 4. I mean, 3 and 1. Okay? Those ones had like all the variables on one side. It was really kind of messed up to try and solve for your variable. This one, it's already solved for y, which makes it awfully easy to take the part here and plug it in for y. So I'm going to use substitution. I'm going to use it because I already have one variable solved for. And that's going to make it a little bit easier in getting the rest of the numbers. So that top equation with the bottom one substituted in is going to look like this. Make sure you put your parentheses. If you forget your parentheses, chances are you're going to forget to distribute that negative, distribute the subtraction, and that will end up giving you the wrong answer. So distribute the negative. You got negative 3x. Negative times negative 5x is plus 5x. Negative times negative 17 is plus 17 equals 3. Combine like terms to get 2x plus 17 equals 3. I'm going to subtract that 17 because I'm trying to get my x by itself to get 2x equals negative 14. Divide by the 2 because we're trying to get x by itself still, so you get x equals negative 7. Alright, we got one of our answers already. And once you have one of those, you can plug it into any of your equations up there, up top, and use it to get your other variable. I already noticed that here, my equations are already solved for y, so I'm going to just plug it in right there. It's going to make it a little bit easier to work with. So I got y equals negative 5. I'm going to plug in x, which is negative 7. And I got minus 17. Sorry, I'm running out of space on that side of the screen. But when I combine stuff, it's going to be pretty easy. So I got y equals negative 5 times negative 7 is positive 35. Minus the 17. Still. I have y equals... Hold on. I have to do this the long way because I don't know it off the top of my head. Borrow some numbers here. I'm going to get 8 and 18. Okay, so y is 18. Ta-da! So I got negative 7, 18 as the point. And we are done.